Section 7.6, integration using formulas. Okay. We may need to use integral table to evaluate an integral. Okay. In this case, we need to use substitution or algebraic manipulation to transform a given integral into one of the integrals listed in the table that we introduced in the earlier section, 7.5. Example 1. Find the volume of a solid obtained by rotating about the y-axis. The region bounded by the curves y equal arc sine x, y equal 0, and x is equal to 1/2. So, find the volume of this solid and rotate it with respect to y-axis. So we rotate this one to this way. So the volume of the method of cylindrical shell can be used to get the volume like this. V is equal to from 0 to 1/2 and 2x arc sine x dx from so we know from the table integral u sine minus 1 arc sine u du can be written in this way. So volume is this. 뭔가 조금 here v should be the pi is missing here. So 2 pi times integral from 0 to 1/2 2x arc sine x dx. So since this integral u sine arc sine u du can be written in this way from the table, so this integral v is equal to 2 pi from here to here can be written in this way, so like this. Also, we can do integrate with sage here. Let's see. Okay, for example in section. Okay, this show this graph here. So we want to we draw the graph here and we can do integrate like we did in the earlier section. Next, evaluate this integral. This integral. From here, by the substitution, since we know the table, we have this table. So there are some similarity like this. So this given integral can be written in this way, which the form agree with the formula that we see in the table. Then we use the table in it. For the third case, integral x to the cube cosine x dx, and this is we have seen the table. We have this formula in the table. So this is a special case of this formula in the table. So we can just use this formula in the table to write this. And this also is a special case of this formula, so which can be written in this way. And then this, then all we have to do is use this one, which is a simple case of this one as well, which can be written in this way. So naturally, we have the final answers as is given. And evaluate this one here. Here we use a table like this. So if we have the completing square, 완전 제곱식, we have a completing square, then this can be written in this form, like what we did in here. So this can be written in this way with the substitution, which is u is equal to x plus 2. So this can be written this way, then use this formula to have this and this. And then apply when a is equal to 3, that gives us the answers are like this. So this is just the table. So you see, if we have a table in our hand, then we just simplify the given one to one that we can find in the table. Okay. In this case, this substitution makes the given integration. Actually, this is integration by parts. So we simplify this one with the integration by parts like this, and then we use this is ln of t, and this is 1/2 of ln of 1 plus t squared. That gives us this answer. But eventually, all this can be done with a simple command like this. Okay, for this function, integral arc tangent e to the x over e to the x, which is this. Okay, I'm going to find the indefinite integral of arc tangent e to the arc tangent of e to the x, e to the x over e to the x with respect to x, which is this. Agree with this one, which is same as x minus e to the minus x times arc tangent e to the x minus 1/2 times ln of 1 plus e to the 2x, like this. So now all you have to do is just change the function of those what you have seen in this section to get the answer when it works. Okay? If this comment doesn't work, then what you supposed to do, Mr. Lee? When you just give the function here and try to find the integral of it, if it does not work, then what you supposed to do? You use the substitution or the partial fraction or integration by parts to simplify it as much as you can, and then use this CAS tool for each piece to get the whole answers. Then I think then this tool will work perfectly well for you. Okay. This Hu Mingfu is the first Chinese mathematician who got his PhD in mathematics. And the book that I recently wrote was talking about a Korean mathematician who made the early history of Korean modern mathematics. I called them as the pioneers of Korean modern mathematics. And I hope you can be also pioneers of 21st Korean mathematics. Okay. There is plenty of exercise problems for section 6.7.6 here, so you can try. You know who he is. He's a Russian President, Putin. He told that all educational reform are doomed to failure unless the teachers change and their living conditions changes. I took this photo at the International Congress of Mass Education in 2004, Denmark, at Russian exhibition place. Okay, next, section 7.4. Any question before? Approximate integration and CAS?